My name is Yunlong, and I'm one of the co-authors for this work. First of all, thank you all for coming here, and it's my honor and pleasure to present in such a big global conference. Today, I want to introduce how we can leverage Databricks and big data to train a foundation model, or saying a large language model. Because it is very large and it's pre-trained, and when we use it for other applications, we only need zero shot or only few shot learnings, so we call it foundation model. Such a concept is quite new in recent years. Back 3 years ago, I wasn't even imagining that I can train a model with billions of parameters. But nowadays, with a platform, with big data, and explosive technologies, we can train the foundation model. This is my team that we work together, train these foundation models. We call this IQ time night because it's IQVIA's healthcare time series foundation model. We use this to predict or to do time series forecasting, particularly in healthcare data analytics. One lesson I learned in this practice is that, if you want to, if your task is to specifically for example, predicting RxDX patient volume for forecasting task in a domain, of course, we can leverage the general foundation model, for example, TimeGPT or Google TimeFM. Google TimeF stands for Google Time Series Foundation Model, which is also a foundation model. Also, we have the AWS Kronos. In our practice, we compare our foundation model with, for example, Google TimeF. Actually, we can beat the Google TimeFM by 7% in terms of the MMSE, the mean square error. And the lesson I learned here is that if you have your own large data, and if you have your platform, if you use your domain knowledge, train a locally deployed foundation model for specific tasks, it could beat the general foundation model. That's how we do it. That's a basis where we start from. We first have we pull 50 million time series in our data set. This time series could be, for example, RxDX by month, the patient volume, or we have a lot of data. Oh, by the way, before I proceed, let me introduce our company. Sorry, IQVIA is a large big data company. We are the largest data vendor in healthcare industry. My clients include, for example, could be like Johnson & Johnson, or GSK, these big pharmaceutical companies, for example, and also some media companies. We provide solutions for them, for example, marketing solution, R&D solution. But in order to provide the solution, we need big data, and we need good model to answer my clients' questions. Because we have the large data, so we can afford 50 million time series. We use more than 10 plus data sources, including NPA, NSP, and also some experiment data. We can do it on geo level, on different level. We can do it on different segments. In the end, we end up with 1.2 billion data points here to train this model. Our data sets looks like this. All of them are three-dimensional. On one dimension, of course, it is time series, claim data. You have the time series here. On the other dimension, we have the geometric information. On the third dimension, we could have segments. For example, when we do marketing, we often do segments. So using this three-dimensional data, we have all these data sets. For example, DX, PX, NSP, NPA, channel dynamics. SDOH means social economic data. In this phase one foundation model, we only use the data sets within this circle. What differentiates us is that, first of all, our model is built based on healthcare data. So if we use this model to do healthcare data forecasting, it performs better than general foundation model. And we tried it, we tested using RX, DX prediction, patient volume prediction, etc. Also, because it is pre-trained, so it means that when we use it in another time series prediction, we don't need to retrain it from scratch. We just need few shot learning. Few shot learning or zero shot learning means you just use it. Like you use GPT. You don't provide another training data to your GPT. That's zero shot. Few shot means that you give it a few examples. If you want to predict the, for example, the some RX, DX on hermatology market, you probably will provide few brands, but that's it, few shots. That's few shot learning. Because of the few shot learning, of course, it is more efficient than traditional model if you train from scratch. And also, because it learns everything on all the therapeutic area we have, so it is like a foundation. So it is more stable when we use it to forecast, for example, patient volume in certain area. We don't have the weird spike. You know, when we do time series prediction, sometimes we get a weird spike, the high frequency noise. But if we use the large model, it can significantly reduce the spikes, the high frequency. Also, we have the we can apply it in many applications within IQVIA. We can develop API, UIs based on this. Next, why we choose Databricks in the end? This is something I want to recommend here. We choose Databricks because this is difficult, not because this task is easy. We have these challenges. First of all, the LLM architecture is complex. It has hundreds of millions parameters. We need to design the transformers layer by layer, and I will show the architect later, but trust me, it's not a simple architecture. Second of all, our data is multimodal. It has diversity of sources, metrics, and segments. It could have EMR, claim, and sometimes with genomic or image data. So it's multimodal. Lastly, this is, of course, computational intensive. We must have a good platform to solve all these challenges. And fortunately, Databricks can handle this. And it is very convenient to use, in my opinion, because it has, number one, it has many integrated functions that I can easily use it. Second of all, it's powerful. The platform is powerful. You can use as many GPU as you need. Thirdly, it has the feature engineering tools, the built-in functions. I like it. And lastly, it's also important. You know, when I finish developing this will become a product, or at least it behind a product. And this product has to be widely used in my industry. If my clients, they choose Databricks, if we need to share data, let's say if we want to share, let's say 1 terabyte data between me and my clients. So we need, in old times, back in old days, we probably use SFTP or in Oracle database, but nowadays, people choose to use, more and more people in this industry choose to use Databricks. So we also follow this trend. We use Databricks, and we can share data, and the collaboration becomes easier. This is from high level. How did we do it? First, we need to create the training data set. Of course, like every machine learning model, from small one to big one, we need to collect the data, create the training data set. And then we need to train this data with platform. Let's say we use 3 GPUs and with 128 giga memories in each epoch. And we also we need to track and manage the training process. It takes time to train it. And of course, we need to fine tune. It's not training in one shot. We have to do it iteratively. And in the end, we need to deploy this model to applications. We develop APIs and UIs based on this. That's from high level. In the end, it is fast, and it has good reproducibility, and it also has good scalability. Collaboration between our company and my colleagues become easier. Also, we can work with my clients to do the time series forecasting tasks. Okay, for this one, it is our experiment results. We test our model on several different tasks. We tried to predict NBRX, new to brand RX, DXPX, total TXPX, NSP, and also patient volume, and also promotion. We tested with different areas, and actually, at least in our experiment, for such specific domain-specific tasks, it beat the general model. That's the message I want to say. Major message I want to say today. This is from high level how we design this foundation, this large model here. We use the transformer here, and then we put layer by layer transformer, then output this time series. My presentation is short today. Time is up. Thank you.